Our next presenter
is Warren Chen, Senior Technical Manager with Andis Technology. Warren's presentation topic, Unleashing RISC-V Computing Power in AIoT and Domain-Specific Applications. In his talk, Warren will reveal how software solutions could help to unleash RISC-V computing power. With optimized toolchains, comprehensive IDE, graphical pipeline analyzer and visualizer, and custom extension automation tools, developers can now exploit the full performance of the processors. Combined with software solutions, the demand for performance and power efficiency can be fulfilled in AIoT and domain-specific applications. Please welcome Warren Chen.
Today, I would like to talk about the software solutions of the ND software solutions, the ND IDE, and the BSP and the Clarity. And then we will talk about the tiny ML device and the AI software stacks. And then we will also talk about how to develop security solutions, security applications. And finally, we will talk about the RISC-V ecosystem and the partners. The ND software solution is versatile, and it included the ND IDE with the advanced debug features, and the toolchains, optimized toolchain inside with it, and the ND Clarity is the pipeline analyzer and visualizer, which help the developer to optimize their program along with the source code and the pipeline. And the NN library, it is the compute library. It optimized with the RISC-V DSP and the SIMD and the vector processors. And also we have the ND6. ND6 is the simulator, consistency, modeling libraries, which should help the customer to build the virtual SoC platforms for the functional verifications. And also, we have the Copilot to help the customer to design their custom extensions for the optimizations. We will dive deeper into the NDSci IDE. The NDSci IDE is an Eclipse-based IDE enriched from 70 years of continuous development. We have the big field display for the registers, and support the multi-core development. We can create the multi-core projects in the NDSci IDE, and with separate configurations for each cores for the multi-core development. And also, we have the core grouping features for the multi-core development, and we can send the debug commands to the specified core groups. And we also have function profiling. The function profiling is to show the execution time for each functions. And the MetaLink script editor, the MetaLink editor is very simple to use, help the developers to generate link scripts. The RTOS awareness functions can help the developer to exploit the runtime environment. And also we provide RTOS awareness timeline view for to display the execution sequence history in the environment. Also, we provide the general exception handling. These features help the developer to caught the exceptions from their software in runtime and help them to find the root cause quickly. And we have function code size to display the code size for each functions to help the developer to optimize their code size with our displays. And finally, we have the link script-based UI record and replace for the test automation and the issue reproduction features. The NDIS BSP is the part of the ND side. The fundamental part of the NDIS BSP is the GNU and LLVM compiler. We optimize this, and it supports the microarchitecture optimizations and the link time optimizations, and further performance enhancements for it. And the optimized the libraries and the compute libraries for DSP, vector, and the neural network. And also we have fast model and the cycle accurate model simulators, the NDSync, NDSync, and QEMU. And they have a debugger, and we have some bare metal drivers and demo programs for the developer to have a quick startup for the RISC-V develop. We also have the real-time operating system portings for the developer's reference, the free autos porting and the Zephyr, especially the Zephyr. And this Zephyr porting is the first RISC-V Zephyr porting supports SMP cores, and we also have the commercial port for the Andes, and they also have the Linux and middleware software framework supports the Linux kernel, and is the for the version 4.5 LTS version, and the advanced features and the U-boot, OpenSPI, and so on. For the NDISC Clarity, you can see it's a powerful plugin for the NDISC IDE. It visualizes the precise pipeline and status and provide data along with the source code. The store bubbles will mark it with different colors in the pipeline, and when you click on the store bubble, it will show reveal the reason why it's stored. And the developer can adjust the execution to to optimize the program. Yeah. And we also have the custom extension. The custom extension is to help the developer to design their own custom extension for the acceleration. This has been discussed before with the Charlie and the John, and also I also revealed with the Copilot tool. NDISC IDE have the integration with it. We can show the original program and the optimized program, and compare their performance. We can see the execution cycle was reduced with the part marked in red. Yeah. Now let's do a little summary for the software solutions. NDISC cores, RISC-V cores provides performance efficiency in area and power, and it has advanced computation power for the DSP and the vector processors. So for the computing optimization, and this provides neural network libraries, vector library, and DSP libraries for the out-of-box acceleration. And also, we can get the benefit of the optimization from the custom extension design. Okay, the last one is for optimization toolchains and the comprehension IDE simulator and tools. We mentioned before for the NDISC IDE with the advanced debug features and the optimized toolchains and pipeline analyzer and the simulator. They also can help the developer to discover the program and the performance bottlenecks for the optimization. Let's look at the diagram. The diagram reveals the spectrum of the AI applications. From edge AI to cloud AI, we can show the tiny ML device was in the first cycle, and it is ultra low power device, and with sensors. That means the tiny ML device is always on with the battery, and the on-device sensors or cameras, and have the capability for the data analytics. And also, you have the machine learning algorithm inside. That is a challenge for having a computing power with low power consumption. Let's look at the ND solution to fit your AI from edge to AI application. There is a wide range. It's from 30 mega operation per second for over 100 tera operation per second. The ND cores, from computation point of view, the ND cores support the N series, which is the baseline power efficient processors. We need more power. We have the DSP SIMD supports for the processors. That the ND series is capable for the tiny ML applications. We have the pros of the low power consumption and the computation power. And finally is the RISC-V vector processor series that is especially suitable for the data-intensive computation from edge to cloud applications. Let's look at this tool and the software stack for AI. We want to develop AI applications. We have the ND core on the button. How we to start the development? The NDs provides the LLVM compilers and the corresponding compute library for each course, the DSP, the vector, and the NN library. And then we have remembered the features of the tiny ML applications require the sensors and data analytics. So it will have the features for the processing for the audio, video, or voice, image. Besides, we also have the AI framework with it. The developers should have the AI framework and the training for their ML models on the desktops, and then optimize the NN models. Finally, they have the NN inference engines like TensorFlow Lite Micro, or TVM. These tools can work with the ND's LLVM library compiler and connect to our compute library to get the accelerations. And the ND-side IDE also play an important part of the development. For these tools, we can develop the AI applications easily. There's also our partners around the functional blocks and have the corresponding solutions to these features. Let's talk about the ND's DSP software solutions. How do we get the benefits from the RVP instructions? NDs provide the compiler, which can automatically generate partial RVP instructions. In addition, the DSP intrinsic functions in the toolchains allow the developer to call it like C-like function without writing assembly codes. And we also have DSP libraries, which is the superset and compatible with the CMSS DSP API. You can see the power efficiency of our DSP applications. We can get the DSP features from the speed up from 2 to 5.5x speed up in codec applications, and we get the 8.9 to 14.5x speed up in the neural network models. For the vector, we also have the compiler support for the auto vectorization to generate the partial RVV instructions, which is facilitate the developer without writing assembly. And the RVV intrinsic functions just works like the RVP. It is the C-like functions. The developer can call it without writing assembly. And our ND's vector libraries is the superset and compatible with NE10 library APIs. And we can show the speed up of the acceleration. It can get the 14.4x to 26.6x speed up based on different vector configurations. Let's talk about the NN library. The MN library is the optimized neural network functions for RVP and RVV processors. We can get the boost from the SIMD and the vector instructions, and it's the superset and compatible with CMSIS NN APIs. And we can get the accelerations with the RV32P processors from 6.7x to 8.4x speedups, and for RV 64P processor from 11.3 to 13.9x speed up. And for beta processors, we can get the speed up from 29 to 48.7x speed up based on different configurations of the vector. The NN library support in 8 different categories. Here is the use case. We can look into the use case and know the benefit of the RVP processor for the tiny ML device. We can see the CVA10. Our libraries support for each level of the CVA10 operations, and we can get the acceleration compared to the M4 for the RV32P. D25F is the 2.9x speed up, and for D45 is 3.7x speed up. And we can calculate the after a simple calculation, the power consumption if we have the 1 inference per second, we can have the power consumption for about 38.4 microwatts. With this low power consumption and the high performance, we can deliver the tiny ML devices very easily. Let's discuss about how to develop secure applications. The Sandy-centric collaborative frameworks help you to establish the trust execution environment. The ND-centric was a portfolio of security solutions, including ND solutions and the partner solutions. We can see the non-secure. In the non-secure platform, we have the hardware and the bootloader and the RTOS and the application over the RTOS. And for the security, we need more features in the hardware and in the software for the security applications. We got to have the firmware encryption, root of trust, crypto engine, secure storage in the hardware. And we also have the processor to support the isolation mechanism for PNP, ePNP, and the IOPNP. And then we have verified the integrity of the boot image, the secure boot. And we have to avoid the sensitive data leakage from the debug hardware. So we need a secure debug for the debugger. And finally, we have a secure monitor to construct the isolated zones for the execution environment. Let's look deeper into security applications. The hardware parts of the ND's core, we can see the PNP and ePNP give the processor the privilege control for the access of the memory and the peripherals. But however, we still need another software, a hardware, IOPNP, to control the transactions on the bus to add the memory access and the peripheral. The hardware isolation features, once the hardware isolation is set, we still need to have the software system for the corresponding software for the isolations. We have the secure boot to verify the integrity of the image And then it will also do the initial PMP, ePMP setup. Then it loads the secure monitor. The secure monitor is loaded. It will, based on the description, and further configure the PMP and ePMP, IOPMP for the each ROMs. The ROMs in the RISC-V was equivalent. We can place the RISC and Ts inside these ROMs. They are totally isolated. Let's do deeper in the secure monitor. The secure monitor is the important part of the security applications. It was responsible for privilege management for each ROMs, and also it have the secure monitor service for the ROMs, and you also management the ROMs context switch and the inter-ROM communications for between RISC and Ts. And also, it will management the secure interrupt handling and forward the interrupt to the corresponding zones. And finally, the secure monitor also responsible for the boot image and the management, the integrity and the integration for the bootloader and bring up for the application image for each ROMs. Let's talk about this RISC-V ecosystem and partners. There are lots of companies and open source projects in the RISC-V ecosystem, including AI tools, software and IPs, DSP, audio, vision, development tools, and autos and security. Especially for the security, from the secure components to a secure debug, we have the partners of eMemory, RAM bus, intrinsic ID, secure IC, and the statics inside, crypto prompting for the hardware features. I just talked about before, yeah. And for the secure monitor, the Zaya, microcontainer, and the trust kernel, PON-like enclave, and the HEX-V, the multi-zone. And the virtual open system, they also provide secure monitor to the security. Let's do a summary for the presentation today. The innovative hardware and software provide the performance-efficient solutions, and this course had the pros of the compact and efficient processor for DSP and the inverter. And the optimized libraries was the corresponding software for this course, which would get the acceleration for the DSP, vector, and NN compute libraries. For the further optimization, and this IDE, it has advanced debug features, and the profile tools, autos, supports, DNAS, and optimized toolchains and demos for the quick startup, and provide the productivity of the development and the jump start for the customer development through the compute libraries. And for the advanced debug features in the multi-core debugging, autos awareness debug, and the timeline view, it also help the developer to explore the runtime environment and the multi-core software development. And this clarity is especially suitable for the algorithm developers. It's a professional pipeline visualizer and analyzer. It can help the developer to optimize the applications. And the ACE for the custom extension development with the execution and analysis, and it could be integrated to the co-work with the NDSI IDE. The ND partner and the RISC-V ecosystem grows continually and will deliver better solutions in the future. Thank you.